The countdown hits 0, the highly anticipated software update goes live, and the system immediately buckles. Or worse, just weeks before launch, the engineering team hits a technical wall and announces an indefinite delay due to a cascade of unforeseen errors. Large software changes, like a new calculation engine or a total architectural shift, require months of work. To keep this incomplete code from breaking the current system, development teams traditionally move all of that work into a separate, isolated workspace. This is the long-lived parking branch. For weeks or months, a team builds a massive new feature in this private silo, keeping the unfinished code completely disconnected from the live software. But the rest of the project doesn't stop. While the parking branch stays fixed on its original assumptions, the main software advances daily. Other developers fix bugs, update interfaces, and change the very environment the new feature was designed to inhabit. When the team finally attempts to rejoin these two paths, they face a massive integration event. Because the main codebase has evolved, the outdated branch no longer fits. This creates extensive merge conflicts and structural failures that can take weeks to resolve. This all-or-nothing approach turns development into a high-stakes gamble. By hiding the work until the very end, the team creates a scenario where a single integration error can prevent the entire project from being released to the public. Avoiding this trap requires a shift in how teams view progress. The goal is continuous releasability. This principle states that while unfinished features are allowed in the codebase, the software must remain in a state where it could be published at any moment. To understand how a digital system stays releasable, we can look at a physical space. A live software project functions like a family phone, and a public release is the equivalent of hosting a dinner party. If you renovate every room in the house simultaneously, the building becomes unlivable. You cannot invite guests over when the floors are missing and the plumbing is disconnected, even if the new kitchen will eventually be world-class. You might try the parking branch strategy, building a replacement room in a completely different city, spending 6 months perfecting it in total isolation. But houses settle. While you were away, the original walls shifted and the floor heights changed. When you bring that off-site room back, it jams. The plumbing doesn't line up and the structural supports have moved, making the integration a disaster. You cannot shut down a living system to upgrade it, and you cannot build its most critical updates in a vacuum. To stay functional, the renovation must happen in connection with the rest of the house. The successful strategy is to build the new room directly inside the active house, but keep the construction area isolated behind a temporary sealed wall. In software engineering, this is known as dormant code. Developers break a massive initiative into tiny, reviewable stages. They merge new data structures, internal functions, and interfaces into the live project every day. This code exists in the system, but it is not yet connected to the parts of the software that actually execute. Because this work is dormant, the system stays stable. Users navigate the software and run their models without ever realizing they're walking right past a massive active construction zone. Integrating unfinished work in plain sight allows the team to identify conflicts as they happen. The project continues to evolve, and because the construction is isolated, the software is always ready for the end user. This approach requires high discipline. Dormant code is not dead code, and if a team leaves unfinished work behind closed walls without a plan, it eventually becomes a source of technical rot. Developers prevent accidental activation using feature flags. A visual gate forces all traffic down the established path, keeping new logic isolated. But dormant code isn't stagnant. Automated tests cycle through the hidden pathway, ensuring it works as the surrounding system changes. Managing this requires a human element. Every piece of hidden work must have an assigned owner and a strict schedule for activation. If a feature is abandoned, the dormant code is removed to keep the system clean. When the work is finally complete, the team avoids the traditional high-stakes merge. They have already integrated the code piece by piece over several months. To launch, they simply update the configuration to route data into the new implementation. The new architecture becomes active instantly within the live system. Users gain access to the new capability immediately, finding a fully validated feature that has already been surviving in the production environment for weeks. Gradual integration turns software development into a resilient, continuously adapting ecosystem. It replaces the risk of massive, system-breaking launches with a series of small, predictable improvements that keep the project always moving and always ready.